when we look at ellipses, sometimes what we might be interested in is finding what the slope of a tangent line is. But the first thing we probably want to do is get a visual of the figure itself. Consider the ellipse, x squared over 3, y squared over 12 equal 1. Find the equations of the tangent at a point where x equals square root of 2. Well, if you look at this, the major axes for this one is going to be, square root of 3, negative square root of 3. This will be square root of 12. This will be negative square root of 12. Okay? And then when you make this thing here, the square root of 2 is going to be here. But how many different places is square root of 2 going to have a tangent line? 2 of them. One here and one here. One will be positive and one will be negative. Let's find the equation of the tangent line first. 2x over 3 dx dx plus 2y over 12 dy dx equal, what's the derivative of 1? Thank you. So that's a terrible mistake to make. 2y over 12, or pi over y over 6 dy dx is equal to negative 2x over 3. So now I'm going to solve dy dx, and I'm going to get negative 12x over 3y, which you could simplify to 4. Okay. So for the first one, finding the tangents, the slope is going to be found by taking negative 4 times x times y. Well, I know x. Do I know y? Eric, how am I going to find y? Don't need to integrate it. Just plug it into that. So we're going to get square root of 2 squared is 2. So 2/3 plus y squared over 12 is equal to 1. So 1 minus 2/3 y squared over 12 is equal to 1 minus 2/3 is 1/3. Do you see how y squared is going to be equal to 4? Y is going to be plus or minus 2. So is that reasonable if x is a square root of 2 that we'll have two y values? One below and one above. So we have 2 points. We'll have one that's square root of 2, negative 2. And the other point we're going to have is square root of 2, positive 2. Now, what's interesting about these is this one down here is going to have a slope. X is the square root of 2 over 2. So this is going to be, this one up here is going to be a negative 2 square root of 2. And this one down here is a positive 2 square root of 2. How did I do that? Well, the slope is negative 4 x over y. So down below here, the slope is equal to negative 4 square root of 2, and y is negative 2. So these will cancel, making it 2 root of 2. And then up here, they're not going to cancel, giving it negative 2 root of 2. So then my final answer is, for the point root of 2, 2, that's going to be x minus root of 2 times a negative 2 root of 2 is equal to y minus 2. For the other point, negative, or square root of 2, negative 2, that one is going to be x minus root of 2 times 2 root of 2 equal to y plus 2. Those are my two answers for the two lines that are tangent to the ellipse at that point. Pretty powerful math. You use that for engineering, physics, whatever. Now, you'd also use it for physics and engineering to know what the normal line is, because if you're on a slope, you can apply forces normal onto objects. So you might want to know these two equations, this one and this one. Well, what's the only thing we have to worry about? We've done all this work. What's the only thing with normals that you have to worry about? Slope. The slope is not going to be negative 4x over y. What's it going to be? Y over 4x, positive. And then could you put you're going to be given a y, you're going to need you're going to have two x's, 2 points. Is that okay? Do I need to do that? It's the same thing, just different values. Say they